There's our objectives and our state standards today that we're going to use with the geometric series. Notice that I'm going to have you identify both a finite and an infinite. So that's probably something maybe we aren't quite aware of yet, of an infinite sum of a geometric sequence. How can we add together an infinite? We'll talk about that here in a second. So I don't have a good story like I did with Gauss for where this formula is derived from. It's a little bit more complicated. So it's the sum of the however many terms is the first term times 1 minus r raised to the n number of terms divided by 1 minus r. So it's a little bit more complicated, if you will. Would you? So again, I will give you the formulas, so we should be fine. And I never thought of this. Maybe you guys just want to find the nth rule and use the sigma if it's on it with a calculator. So find the sum of the first 10 terms of this geometric sequence. Here's our first term. What's our ratio, guys? 5. And if we go back and we look, hey, all we need is the first term and the ratio. That's it. So let's get this then. So we're going to find the sum of the first 10 by taking, what is our first term? It's what? 1 times 1 minus, what is it? R to the n. So what's our ratio? 5 raised to the 10th over, what? 1 minus, what's our ratio again? 5. Okay? Always takes me a second to make sure I'm right on my formula here. So grab your calculators. Now just listen real quick before you type it in. I was raised with not quite as nice of a graphing calculator that you can put it all together. So when I look at this, I would go, if I was typing in, now don't do it yet, I would just go 5 to the 10th and then go 1 minus that answer, enter, divided by -4, enter, multiply it by whatever's in front. I think most of you can type it in almost exactly the way it looks, and you're going to get the right answer. Let's type it in. Let's see how we do. Okay, so I'm gonna go to my calculator as well. Help me out here. So I don't need to go 1 times. Could you put the whole thing in? Could you go? Yeah. So I gotta go parentheses. I'm gonna go parentheses again. 1 minus, what was it? 5 raised to the 10th. I'm probably overkilling parentheses, but I go, okay, here's that. See how I have the numerator as one parentheses divided by, because I don't trust, again, I was raised old, oh, sorry. Were you guys going to just keep staring at me, or was somebody going to say something? Y'all stare, go ahead. I can't wait. I hope one day I'm sitting at like some National Honor Society induction meeting and you're giving the speech or something and your fly's going to be down or there's going to be a booger on your nose and I'm just going to look at you. And you're just going to I'm not going to tell you. I'm not going to be your friend. Tell me.
Well, what would be more awkward? During the speech, you like reach down and zip it? Or like
I would walk up there and be your friend and like in your ear like, hey, your fly's down. I would be your friend. I would be your friend.
You just said you would.
I would be your, okay, well, I would, except you all have been mean to me, so now I'm going to be, I told you my first day ever as a teacher, right? Ever?
No.
My very first day teaching. Sorry. First day. All right. And then what? 1 minus 5? Like that. And then I got to close it. Is that the right answer?
Yep.
So 2,441,406. How soon till the graphing calculators put the commas in for you? No, how soon till they have that program where it'll give you that too? Really? There you go. The iPad TI one?
No, like just like
The generic one? Okay, there you go. All right, we good with that? It's guys, it's that easy. It's that easy.
Just that easy.
It's just, okay. So, find the sum of the first 5 terms of this geometric series. So we're going to find this by finding the sum of the first 5. And I know we could just add them together. Let's write the formula. Our first term is what? Negative 60. You always got to be careful with the negatives. And then it's 1 minus, I got to find my ratio. Negative 1/3. Look up here. 1 minus negative 1/3 in parentheses raised to the 5th over 1 minus negative 1/3. So what should we do with that minus negative in the denominator? You have it written like that. Now it's not as this parentheses around this raised to the 5th is very important. Now, it doesn't hurt us with the raised to an odd power, but if we raise that to an even power, what's going to happen with that negative? It's going to become positive. Okay, look, you guys go to your calculators, and let's see if we can get it. The nice thing is you guys, these calculators are so much more updated. It works really well.
I got 61. That's what you do. That's what I got. I kind of get.
Doggone it. All right. I got to go to the calculator. That's what we should be getting right here. Okay? Now let's go back to here. Let's write the sigma rule. What would the sigma rule be? It'd be the let's do that. Let's do it that way. Let's write the sigma rule. So the sigma from n equals 1 to how many terms? 5. And now we have to write the first 5 terms. Now we have to write the rule. What's the rule for a geometric sequence? It's first term, negative 60, times ratio. What did we say the ratio was? Raised to the n minus 1. Type that in our calculator. See if we get the same answer. What was the answer supposed to be? Negative 1220 over 27. Let's see if we get the same thing if you type it in that way. Nice. Guys, I'm okay if you go and convert it into sigma and then get me the answer. You guys like doing it into sigma? You guys like converting it into sigma? I think it helps. Okay? Just real quick, what would I have to find? So I gave you the first term, good. I gave you the fourth term. I'm asking you to find the 8th term. What do we have to find first? We got to find the what? Ratio. We're going to find the ratio of a geometric by taking what? 512 divided by 1, and then we're going to take the what root? 4 minus 1 is 3, so we're going to take the cube root. So what's the cube root of 512? I don't know that off the top of my head. 8, thank you. So then, I'm gonna go straight to sigma. My student yesterday's convinced me that's the best way. From the 1st to the 8th, my first term's 1. My ratio is 8 raised to the n minus 1. I like that. I'm just going to type it in. Bam. feel free to do it also. Or you can use the geometric series formula. I'm okay with either way. Is it just me or did it get really cold in here? I turned up the heat. No? Okay. We had all the windows open in our house last night. Anybody else do it? It was wonderful. It was so nice and cold this morning. It was wonderful. My daughters didn't think it was wonderful.
Not what I got.
What do we get for this? Anybody type this in?
I got 3,641.
3,000.
I got 2,396,745.
That's what I got.
That's what I got.
What'd you get, Vance?
2,396,745.
2,396,745. Anybody else getting that?
Yes.
Chloe, fix it.
I'm not in bed.
Did you do the formula?
I did it like that.
Your ratio is 8. Look, come here.
Oh my, yeah.
You have the ratio being -8. That's going to
Okay.
really take us the wrong way.
I was gonna, okay. For this one, the n equals 1, so is it always the first term that n equals, or is it
First.
just always n equals 1?
It's because we're starting from the first, we're finding the sum of the first 5 terms, so from 1 to 5.
Okay.
If I said find the sum of the first of the, remember I showed you the last class from the 3 to the 9 or whatever,
N equals 3.
the first term, yeah, it'd be, yep.
And then it's always n to the raised to the n minus 1 power.
That's the rule, yeah. So I feel like these all right here are going to be all the same. So I don't think we need to keep typing in our calculator. Let's do this one. Let's do number 6. Okay, I'm asking you to find the sum. Stay with me, guys. I'm asking you to find the sum of the first 13 terms. I tell you the 5th and I tell you the 7th. So we got to find the ratio real quick. So let's find the ratio. Now remember, be careful. Don't take 64 divided by 16. It's always the latter term, so it's 16 divided by 64. And then 7 minus 5 is 2. So basically take the square root of, what is that? 1, that's 1/4. What's square root of 1/4? 1/2, wouldn't it? It's okay. It's all right.
Good try.
So then, if my ratio is 1/2, I also need to go back and I need to find the first term. Does everybody agree with that?
Yeah.
Let's just make it happen. If this is my 5th term, 1, 2, so 4, 3rd, 2, 1, I would just go backwards 4, right? If my ratio is 1/2, look up here. That's if I'm going this way. What's going backwards?
Multiplying by 2.
Yeah, let's just do it real quick. Take 64, and you're going to multiply it basically times 2 to the 4th. Are y'all with me on that? What's that first term? Ethan, what's 1024? And then, you guys want to do the formula or you want to do sigma?
Sigma.
Anybody want to do the formula? Okay, let's do the formula. That way we can have both covered. The sum of the first 13 terms would be my first term, 1024, times 1 minus my ratio, which is 1/2, raised to the 13th, over 1 minus ratio 1 minus 1/2. So this should be equivalent to this. We should be, so whatever way you're doing it, we should be getting the same thing. Let's let you guys plug that in and let's find out. Convert it to a fraction, Mike. Let's see if it comes out clean. I know it's 0.75 and that's clean that way. So
So 8,191 over 4.
8,191 over,
4.
or as a decimal is 2,040. 247.75, which are the same thing, yes?
Yeah.
Anybody else getting these?
Yeah. Yeah.
Okay, so since this decimal is a finite decimal, I'm okay with this. Y'all with me? But if you, I got you kind of in the habit, if you want to convert it to a fraction, either way, this probably has more meaning to me. What's the sum? 2,047.75. What's the sum? 8,191 divided by 4. That doesn't quite have the same meaning. Questions? Okay. So I think we have this covered, don't we?
Yeah.
What's your first term? 6. What's the ratio? 2. We'll find the sum of how many terms? The first 10.
Do we do when you're like,
It doesn't start from the first term?
Yeah.
Yeah, we can do that again. So let's just, let's go back and let's just change this one from, let's just change this 1 to a 3. Cool? So then I'm going to find the sum. You have to be careful here then. So if we're thinking about this, look, everybody look at me. Look at me. 3, 4, 5, 6, 7, 8. It's 6 terms. It's not 8 minus 3. Basically, you go 8 minus 3 plus 1 because you got to count that term. So we're finding the sum of 6 terms. And with that being said, 5 is not the first term. The ratio's 4. What's my third term?
Wait. That's not the first term, right?
This is the first term if we were starting with the
That is
first
the
term.
first term.
But we're starting with the third term. It's 80. How'd you get that? Well, if the first term's 5, if the first term's 5 times 4 is 20 times 4 is 80. 1 minus, what's our ratio? Raised to the n. How many terms did we say again? Remember when I counted on my finger? It was 6, right? Over 1 minus 4. Now, you could type it in this, Ashley, what we just wrote up there. This should be equivalent if I type this into my calculator this way.
how did you have to change the 5 to 8?
No. Nope. This 3 here, putting this 3 in here, took care of that. Knowing that you're going, so that you would type it in exactly like that, Lainey. This should be equivalent to that. Check me. Hold me accountable in our thought process.
Change the 5 to 80, would you have to put the 3 as well? Technically.
Yeah. And then you'd have to change that 8 to 5. So that's why you don't want to do that.
So because 1 is 80, the first term is 80, and the third term is 5. What? That's what.
This is the rule for the rule for geometric series. First term times ratio raised to n minus 1.
Yeah.
So if I'm going into the formula and I have a 3, first term's not 5. The first term from starting with the third term is 80. The first term using this formula. Did anybody type them in both and get the same thing?
It was
Okay, what was that answer, Abby?
109,200.
Okay. I'm going to get to the story problems, let you guys have a chance to work. But before we do that, let's talk about infinite geometric sequence. All right, we can find the sum of an infinite geometric sequence only when the absolute value of our ratio is less than 1. if the absolute value of our, so when I say absolute value, I don't care if it's positive or negative. The absolute value means it becomes positive. If the ratio is bigger than 1, then the sum of an infinite series does not exist. It actually equals infinity. Let me explain what I'm talking about. If your ratio is 2, it's bigger than 1, right? And I said find the sum of an infinite amount of it. Well, think about it. I'm always going to keep multiplying by 2. We're never going to reach the end. That's why the sum of an infinite sequence would never exist if the ratio is bigger than 1, because I'm going to get to infinity. But if my ratio is less than 1, 3/4. Say if you start with the number 4. Let's go 1. Start with 1 times 3/4 becomes 3/4. Times 3/4 becomes 9/16. I'll write it down so you can see it. So if I started with 1 and then multiplying by 3/4 becomes 3/4. 9/16 times 3/4. 27/64. What are you noticing about these fractions? They're getting smaller and smaller in value. If you keep multiplying infinite amount of times, that value, that fraction is going to approach what number? 0. Therefore, I can have a sum of an infinite sequence. So everybody ready? Think about this one. This is the one that helps everybody understand it. Think about grandfather clock, little pendulum swinging, right? So you swing it, and then the power dies to it or something, okay? Each swing becomes a little bit and a little bit smaller. Now, why is it a sum of an infinite? Well, it's going to approach eventually. The pendulum's movement is 0. But because we all know that without somebody coming and pressing against that, there's still those electrons, if you will, are still moving. It's just, it's so microscopic. We can stop. We can just go ahead and say 0. That's what a sum of an infinite geometric series is. Okay? Hopefully I got the point across of the ratio has to be less than 1. So find the sum of this sequence. Well, first of all, check your ratio. 2, 2/3, 2/9, 2/27. What's your ratio? 1/3. Right? And we just saw that it's simply the first term divided by 1 minus r. So all we're going to have to do is go first term divided by 1 minus r, 1 minus 1/3. I mean, we don't even need a calculator for this one, do we? 2 divided by 2/3, which is the same thing as multiplying by 3/2. 3. Let's do another one. Oh, I skipped one. Yep, no. Find the sum of this sequence. Who's got it worked out?
Infinity.
Levi? Infinity. Why? Ratio is bigger than 1. That was the world's worst infinity, wasn't it? Like, that was bad. Let's see if I can redeem myself. What do you mean, no? That one's awesome. All right. All right, so here you go, example of what I just said. On its first pass, a pendulum swings through an arc whose length is 24 inches. So the arc of the length is 24 inches. On each pass thereafter, the arc length is 75% of the arc length on the preceding pass. Find the total distance the pendulum travels before it comes to rest. So because it's the ratio's 75% of the previous, obviously the ratio is less than 1. So the sum of this infinite series would be, what was the length of our first pass? What was the first term? 24 divided by 1 minus What's the ratio?
3/4.
So 1, you gotta be careful. The arc length is 75% of the previous. So you're gonna multiply by 3/4. It's not, I didn't say 25%. I know what you guys are thinking. You're thinking that percent growth, that 8% from the time before. Okay, I'm telling you it's already 75%. How do you get 75% of something? You multiply it by 3/4, don't you? So 1 minus 3/4, which is 24 divided by 1/4, which 24 times 4 would be 96. So in this case, it'd be 96 inches. What do you guys think? Okay?